All right, today we're taking on just a mixed practice with all of the different segment relationships inside of circles. So first up, I'm telling you that line AB is tangent to circle O. O is the center of the circle. Find X, simplify any radicals. Okay, so anytime we see a tangent line and a radius, we know that those pathways run perpendicular, gives us a right angle right there. And we know that any radius is going to match any other radius inside of the same circle. So I have X right here. So this whole side right here must be X plus 18. Okay, and then to find X, I can really just use Pythagorean theorem. So I know that X squared plus 24 squared is equal to X plus 18 as a quantity squared, right? A squared plus B squared equals C squared, classic Pythagorean theorem. So now I have X squared plus 576 equals X plus 18 times itself. Whenever I see a binomial squared, I need to view it as two separate packages that have to be multiplied out. We have to FOIL them out. So on the left-hand side, I still have X squared plus 576. And on the right, the first part is X squared. The outer is plus 18X. The inner is also 18X. And then the last, 18 times 18 is 324. All right, now I combine my like terms. I have X squared plus 576 equals X squared plus 36X, right? I'm just combining my like terms right here, plus 324. Okay, if I subtract X squared from one side, it's going to clear it from the other side as well. So now I really just have a linear equation. I want to subtract that 324 over to the other side. So now 252 equals 36X. Divide out the 36 from both sides. And I end up with X equals 7. Okay, if I double check that, if I have a 7 here, a 24 here, a 7 plus 18 is 25, well, that's a common triple, a 7, 24, 25. So I know that I've solved it correctly. I recognize that pattern. All right, next one, I'm going to do the same thing. This one has a little bit more algebra involved. So here again, I have a tangent line. I have a radius. We know that they always run perpendicular right there. If this is 2, then this is also 2, right? Any radius is going to match any other radius in the same diagram. And then this whole segment has to be X plus 2. Okay, back to Pythagorean theorem. So I know that 2 squared plus 5 squared equals the package of X plus 2 as a quantity squared. So now 4 plus 25 equals X plus 2 times X plus 2. Right, I know that I'm going to have to FOIL that out. So 29 equals X squared plus 2X plus 2X plus 4. So 29 equals X squared plus 4X plus 4. Okay, I want my quadratic equation set equal to 0, so I subtract 29 from each side. So now 0 equals X squared plus 4X minus 25. So now I stare at that and I think, can I factor that? Is there something that multiplies to a negative 25 that adds to a positive 4? And we come up with no, right? There's no way to factor this. So I'm going to take it to the quadratic formula. I know that the A value is 1, B is 4, and C is negative 25. So let me continue that up here. All right, so x equals negative b, so negative 4, plus or minus the square root of b squared, so 4 squared, minus 4, a is 1, c is negative 25, all over 2a, 2 times 1. And again, whenever I see a mistake, it usually happens in here, right? Usually I see a sign error. So I'm going to keep my eye on that to make sure that I don't make that mistake. So x equals negative 4 plus or minus the square root of 16, negative 4, positive 1, negative 25. That multiplies out to be a positive 100, and then all over 2. So x equals negative 4 plus or minus the square root of 116 all over 2. Now 116, right, I want to simplify that. So if I'm thinking of what goes into 116, well, 4 goes in 29 times. So let me just double check that. 16 divided by 4, 116 divided by 4. So I see that that is 4 times 29. So that's going to be 2 root 29 right there. Okay. So now keep working to clean it up. X equals negative 4 plus or minus 2 root 29 divided by 2. So that 2 is like a common denominator for that negative 4 and this 2 root 29. So if I'm going to simplify, I need something that goes into all 3 of these terms, and they're all divisible by 2. So now I end up with negative 2 plus or minus the square root of 29. Now remember, that gives me 2 solutions. That gives me negative 2 minus root 29 and negative 2 plus root 29. Now, x has to be something that's positive, right? I can't have something negative right here, and this right here would produce something negative. So that one is out. That cannot be my solution. I need the solution that produces something that would be positive overall, and that would be this second choice of negative 2 plus root 29. All right, next skill. Let me slide this up. All right, use the diagram of circle O to find the indicated lengths, simplify radicals. So we're told that WT is tangent at to circle O at point T, and that OA is 7 and NK is 3. Okay, so really what that's giving me to build off of is that a radius is 7. So I must have a 7 here. This radius must be 7. So if this is in total 7, this must be 4 right here. This must be 7 right there. Okay, I'm also told that this is a tangent at point T. This is a radius. So I must have a right angle in here, which shows me that I have a 30, 60, 90 triangle right there. So let's say that I build off of that first. Let me sketch that to the side. So if that's a 30, 60, 90 triangle, right, that's my x, that's my x root 3, that's my 2x, and my x root 3 side is 7. So if I'm trying to solve for x, okay, I can say x root 3 equals 7, but I'm really dividing by root 3, and then I'm rationalizing, right, multiplying by root 3 over root 3. So 7 root 3 over 3. That is going to be this side right here. 7 root 3 over 3. Here, 7 root 3 over 3. And then I just double it. I multiplied that by 2. So that's going to get me 14 root 3 over 3 for right here. Okay, so then I also want this measure here, and I see that that's a right triangle. So if I visualize that right triangle here, right? That's 7, that's 4. So I can use Pythagorean theorem or the shortcut that gets me my missing leg. So I can say square root of my hypotenuse squared minus that leg that I do know squared. So square root of 49 minus 16 gets me 33. So root 33 is this missing side here, which is the measure here. And if I have a radius and a chord that run perpendicular, that chord gets bisected. So this segment here and this segment here are the same. So also root 33. Okay, I filled in all my gaps. So now to the right, if I'm asking for AT, that's a diameter, must be 14. ON, right there is 4. Okay, SN right here is root 33. If I want XS, if I add those two together, I have 2 root 33. And then OW, I have 14 root 3 over 3. All right, there we go. Okay, next up, find the radius of circle B. So right here, I see that I have this perpendicular pathway that connects the center, and if I kept going, would eventually hit the circle, right? That would be a radius, and this would be a chord, and I'm showing that that pathway and that pathway run perpendicular. So this chord is getting bisected. So I'd have a 10 here and a 10 here. Those segments are congruent, giving the little tick marks. Okay, and if I connect point B to the circle right here, I've really just made it a right triangle, where this is 5 and this is 10. The radius is the hypotenuse of that triangle. So again, I can go back to Pythagorean theorem, where I can use my shortcut, where it's the square root of 5 squared, right, a leg squared, plus the other leg squared. I'm trying to get to the hypotenuse. So 25 plus 100, I'm at 125, right, and that's 25 times 5. So I get 5 root 5 when I simplify. So my radius, right, my center to any point on the circle has to have a measure of 5 root 5. Okay, next up, here I have several tangents to my circle, right? I have a tangent here, here, and here, because I see the one point of contact, here, here, here. So point of tangency, point of tangency, point of tangency. So if I picture them here, right, this tangent right here, this tangent segment that connects that point of tangency to this point on the exterior, and then here's another point of tangency, same point in the exterior. Well, these have to match this region of it, right? This tangent segment to this tangent segment. So this must be 7 right here also. Okay, if I picture this portion here, another tangent segment that would have to be the same. So 19 minus 7 tells me that this portion would be 12. Which means that this portion here must be 12. Okay. And then right here, right, again, I have this tangent segment here. They have to match. If this is 25 and this is 12, this part has to be 13, which means this part has to be 13. So the part that I ultimately want is 13. So even though I had those big tangent kind of pathways, right, touching the circle one spot, right, I'm really focusing on these two here that are the same, these two here that are the same, and these two here that are the same, right? I'm just trying to connect where their points of tangency fall. All right, let's flip a page, go to the back. So here's some mixed practice. So this first one here looks like I have 2 secants. So a secant pathway, and here, right, just a portion of a larger secant line. So here's the hole, the outside, the whole, the outside. So I'll start by writing that. Whole outside, just like that. Okay, and then I'm going to mark what the whole is. 11 plus 7 is 18. And if I add x plus 2 and x minus 2, I really just get 2x, right? 2 minus 2 is 0. So my whole is, let's say I start here, 2x. The outside is x plus 2 equals, the whole here is 18. The outside is 7. So if I distribute that 2x, I get 2x squared plus 4x equals 126. I'm going to subtract that 126 from both sides. I want my equation to be set equal to 0. And then I'm hopeful that I can factor it and then solve. So when I look at all of my terms, I see they're all even. So I divide out my GCF of 2. So x squared plus 2x minus 63, all equal to 0. So now I'm looking for two numbers that multiply to a negative 63, but add to 2. So 2 times, looks like it's going to be 9 and 7, right? Negative 7 and a positive 9. So here I have 2 times x plus 9 times x minus 7, all equal to 0. So set each factor equal to 0 and solve, and we get x equals negative 9, x equals positive 7. But can x equal negative 9? If I plug it in here, it gets me something negative. So I know that that solution is out. It does not actually work in the context of our problem. So x equals 7 is the only solution that actually works. Okay, next problem. It looks like we have two chords, right? I see a chord here and a chord here. Here's that point of intersection. So I'm looking at the product of these two smaller portions and the product of these two smaller portions. So I have x times x plus 7 equals 5 times 6. Okay, distribute the x. So x squared plus 7x equals 30. Okay, take away the 30 from each side. So x squared plus 7x minus 30 equals 0. So again, here I need to factor it. So I'm looking for two numbers that multiply to a negative 30 that add to 7. And I should be able to see that it's going to be a plus 10 and a minus 3. So x could be negative 10. X could be positive 3, but can it be negative 10? Can I have a negative right here? No, cannot have negative 10. That one is out. So the only solution that works is the one that is positive, right? X equals 3. So in the context of this problem, that is the only solution that works. Okay, next up. So here I see that I have a tangent and a secant. So I'm looking at my tangent segment squared is equal to the whole secant segment here. So if I add those together, I get x plus 4 times this outside portion, which is the x minus 1. So I have the tangent segment squared equals the whole times the outside. So my tangent segment is x plus 1, quantity squared, equals the whole, which is x plus 4, times the outside, which is x minus 1. So here I'm going to have to multiply that out. So I'm going to write it out as a pair of binomials where I'm going to FOIL it. And then I have to FOIL out the other side as well. So the left-hand side, I have my first, so x squared, outer plus x, inner plus x, last plus 1, equals, first is x squared, the outer, minus x, the inner plus 4x, and then last is minus 4. So combine your like terms. We have x squared plus 2x plus 1 equals x squared plus 3x minus 4. If I subtract an x squared from one side, it's going to cancel from the other side too. So now I'm just trying to solve for x. So if I subtract 2x from each side, now I have 1 equals x minus 4. Add the 4 to the other side, and I end up with x equals 5. And that's my solution, x equals 5. Okay, next up, here I see again a secant and a secant. So whole outside, whole outside. So whole times outside equals whole times outside. This whole part, if I add together, I get 3x's and then minus 6. And then if I do the same thing here, 2x plus 4. All right, so my whole on the top is 3x minus 6. Outside is x plus 2. Down below, the whole is 2x plus 4, and the outside is 9. So I FOIL out the left. So I have 3x squared plus 6x minus 6x, and then minus 12. Distribute the right equals 18x plus 36. Okay, clean it up. So 3x squared, those x's are going to just cancel away, minus 12 equals 18x plus 36. Okay, let's pull everything to the left, make it equal to 0. So I'll subtract the 18x, and I'll take away the 36 as well. So 3x squared minus 18x minus 48, all equal to 0. So now I look for a GCF. I see that that's a 3, leaving behind an x squared minus 6x minus 16, all equal to 0. Okay, I'm looking for two numbers that multiply to a negative 16 that add to a negative 6. Okay, and we should see that that's going to be a minus 8 and a plus 2. Set each factor equal to 0 and solve. X equals 8, x equals negative 2. But again, that negative, if I plug in the negative 2 here, that would make this segment equal to 0, and that is just not possible. So that solution is out. The only one that works in this context is x equals 8. Okay, two more. So these last two, I was going to actually pause and have you try to solve for these two. And then when you're ready, maybe unpause and we can go over them. All right, so I'm just going to start. So for this one, there's really two ways I could do it. So one way I could do it, let's say that I go like this and I draw in a radius, right? I have a tangent segment here. I have a radius now here, and they run perpendicular. And I know that 4 is a radius, right? I know that this whole hypotenuse has to be x plus 4. So option 1 is seeing that right triangle and using the Pythagorean theorem. So 4 squared plus root 65 quantity squared equals x plus 4 quantity squared. So here I have 16 plus 65 equals x plus 4 times x plus 4. Right? I have to FOIL that out in just a moment. So 81 on the left is equal to x squared plus 4x plus 4x plus 16. So 81 equals x squared plus 8x plus 16. Okay, take away the 81 from both sides. 0 equals x squared plus 8x minus 65. See if we can factor that, right? Anything that multiplies to negative 65 that adds to 8. And of course we can. That would be plus 13 and minus 5. All right, so I can say, well, x equals negative 13 x equals 5. And again, can't have a negative measurement here. So x has to be just the 5. Now the other way that we could see this, the other way to visualize it, is if I extended this pathway here and drew in a full diameter right there. This is also 4. So if I picture it like that, maybe I draw a circle. We just say that this is another option. So, or we do it this way. So I can picture that tangent segment of root 65. Here's the whole secant, where this outside part, the external part, is x, and this part here is 8, and this whole part here would be x plus 8. So if I saw it this way, I see it as a tangent secant combination, where it's the tangent segment squared equals the whole times the outside. So root 65 quantity squared equals x plus 8 times x. So 65 equals x squared plus 8x. Take away that 65, and you see that we're in the same spot that we were before. Right? So it's going to factor down the same way. We would get that x equals 5. We're just getting there a different way. Okay, last problem. So here I'm giving you a chord that's being bisected. I'm telling you that this is a radius. I'm marking this part as x. I know that then this chord right here must actually, since it's being bisected, must run perpendicular to that radius. So I can put in a right angle here. I know that AT is 12, so I must have a 6 here and a 6 here. And I'm trying to solve for this little sliver right here. Oh, right here, right? I want that part, that is x. So I can see then that this sliver right here, if I picture the right triangle, this part would be, if this is a radius of 8 and this is x, this is 8 minus x. So I could see it as a right triangle where this is 8 minus x, this is 8, and this is 6. That would probably be how I would see it. So then I could say that I have 6 squared plus 8 minus x, quantity squared, equals 8 squared. So now I have 36 plus x minus 8 times x minus 8 equals 64. Right, I got to FOIL this out. So I have 36 plus 64 minus 8x plus x squared equals 64. Okay, I might see right here that those 64s are going to cancel away. Just gives me smaller numbers to work with. And then clean up what's on the left. I have x squared minus 16x plus 36 is all equal to 0. Okay, so now here I think, can I factor it? Is this going to factor? This is not going to factor. So now I want to solve it using a different method. So I could solve it using the quadratic formula. We've practiced that a whole bunch. Another method is to complete the square. And since we've seen that lately, I'm going to practice it that way. So if I want to complete the square, I'm going to move that 36 to the other side. So I have x squared minus 16x equals negative 36. I take that linear term, that negative 16, I split it in half, and I square it. Gets me 64. So I have x squared minus 16x plus 64 equals negative 36 plus 64. Okay, the whole point of doing that is to create a perfect square trinomial. So this factors into x minus 8 as a quantity squared is all equal to 28. Okay, solve by taking the square root. Let me slide this up a little bit. So x minus 8 equals plus or minus 2 root 7. and then add the 8 to the other side. So x equals 8 plus or minus 2 root 7. But again, right, these are two solutions. That means it could be 8 plus 2 root 7 or 8 minus 2 root 7. So here, if the whole radius is 8, if this is all 8 right here, it can't be 8 plus 2 root 7. That would be too big. It must be the 8 minus 2 root 7 as our final solution. Okay, another way that you could have gotten there, just another option, I'm just going to tuck it here as a possibility. I'll say or. Okay, you could have seen your circle. Let me just draw in that whole pathway here. Right, I'm just going to extend it like that. And then like this, where this is x. Oops, nope, not there. X is right here. Okay, this is 6 and this is 6. And then this whole portion here, let's see, to here where the center is, this was 8. This part here was 8 minus x. So I could have viewed it as two chords where I have my, if I add this up, right, I have, let's see, I have here to here, which would be 16 minus x. Here to here would be x, and then 6 and 6. So I really have 16 minus x times x equals 6 times 6. Distribute. 16x minus x squared equals 36. Let's say we move everything to the right. I could add the x squared and take away the 16x. So 0 equals x squared minus 16x plus 36. And you can see that we end up in the same spot. Let's see, same spot as we were right here, right? And the method that we could use to solve it, again, we could complete the square. I did it by completing the square, but I could have also done it as quadratic formula. That would work too. Some of these problems, they have multiple pathways that get us to the same conclusion. Ultimately, we don't care how you do it as long as we match in the end. All right, that's all I got. Have a good rest of your day.